in this first session today, we have a very important topic, that is the application of meta-analysis in agriculture research. This topic will be taken up by our expert, Dr. Kiran Kumar T. He is a scientist at ICAR NIAP, and he joined ICAR system in 2018 at CSSRI Karnal, that Central Soil Salinity Research Institute, Karnal. And after that, he is serving in ICAR NIAP, New Delhi. And during this tenure of more than 4 years, he has published more than 10 research papers in national and international reputed journals. And his area of interest is agriculture sustainability and ecosystem services. Now, for this important topic of application of meta-analysis in agriculture research, I invite our expert, Dr. Kiran Kumar Ji. Please deliver your talk to our participants. Dr. Kiran Kumar Ji, please, I'm requesting you, please deliver your talk to our participants. Please, Dr. Kiran.
Thank you so much, sir. Thank you very much. Let me share my slide. Sir, it is coming that host a disabled participant for screen sharing. You just enable me to share the screen.
Dilip ji, please enable the. Now you make time?
Yeah, now it's coming. Okay.
Yeah, now it's visible.
Is it visible, sir? Slides are visible?
It's visible.
Yes. Yeah. Okay. Thank you so much, sir. A very good morning to everyone. I welcome you all in today's my lecture on meta-analysis in agricultural research. So nowadays it is quite popular in social science research. So I will try to explain how to conduct the meta-analysis with case study. Okay. So this is the outline of presentation. First, I will briefly discuss why we need to do meta-analysis and definitions, and after that we'll discuss the brief history. Then we will see meta-analysis and different literature reviews. So then basic steps which are involved in while conducting the analysis. Then limitations to meta-analysis. Then finally we'll see the case study. You know, the advancement of any scientific research is based on two important aspects. One is accumulation of knowledge through previous studies, and another one is replication. That is means that findings of studies which are confirmed or not confirmed through repetition by other scholars or other scientists. So these two principles, they suggest that the scientific knowledge should steadily progress over the years. But in reality, you know, this is not the case due to several constraints. You know, one obstacle is that we are also human beings with limited abilities to retain, organize, and synthesize the findings. So in most of the research areas, you know, nowadays there are plenty of research is conducted. So it's very difficult for us to stay informed, very minute details of particular research area. Then another problem is that, you know, studies are not exact replication of one another. So we will use slightly different methodology, slightly different measures, and different samples. So that leads to an imperfect replication. So it makes us difficult to separate the meaningful differences in results due to sampling fluctuation. And if at all, if we know that there is a difference in results, but it is very difficult to locate what are those differences that leads to difference in results. And sometimes, you know, we as a policymakers and researchers, you know, there are huge value of information is available with us, but that information is not give a clear-cut answer to a specific research question. For example, I want to study whether particular treatment is effective or not. So research A shows that yes, it is effective, but research B and C, though they are very quite similar to research A, but they shows that exact opposite result. So which one we have to believe, whether research A is right or research B and C are right. So whether our treatment is effective or not. And also single study, if you, they are not much reliable to find the difference between two treatment. So what is the solution? So one solution is you can systematically review the results from several previous studies, then synthesize it, and then draw conclusion and regarding findings, and you can find out what are the source of variability. So one method of conducting such systematic review is through meta-analysis, so, which is a methodological and a statistical approach. So from that we can draw conclusion. Then coming to definition, it's defined as it's a quantitative approach for systematically combining results of previous research to arrive at a conclusions about the body of the research. So what does it mean? It's a quantitative, means numbers, not qualitative one, and it is systematic, we are doing methodologically. And third is combining, so we are putting together information from several studies. Then previous research, that's what has already done. Then conclusion, we will arrive at a new knowledge. Okay, it is derived from Greek word meta, which means after or beyond, means beyond single studies. Our results are combining, results are from combining different studies. The first definition is given by Ginny Glass. He defined that the statistical analysis of large collection of results from individual studies for the purpose of integrating the findings. And he also called it as an analysis of analysis. Then Huck defined that meta-analysis is a statistical analysis that combines or integrate the results of several independent clinical trials, which are considered by the analyst to be combinable. So the main goal of meta-analysis is integration, that is to draw a generalized conclusion by combining and comparing the previous studies. Then coming to the emergence of this meta-analysis is maybe the Carl Pearson. He's the first person who used the formal technique to combine the several numerical data from several studies. So he combined the data on efficacy of typhoid vaccination. After that, Ronald Fisher actually he laid the groundwork for the meta-analysis, and he wrote a book on that, and which is statistical methods and scientific inference. Then after that, Cochrane, he discussed how to average the means across independent studies. So nowadays, what we are doing, conducting the meta-analysis, the modern one, that is mostly based on Cochrane approach. That is, we generally do his work. That is, it's inverse variance weighting and also homogeneity testing. They developed by Cochrane. So there are two events in the history of meta-analysis that stimulated the much significant development in this area, especially in the psychology. So in 1952, Hans, what he did, he reviewed the available literature on efficacy of psychotherapy, and he concluded that there is no favorable effect of psychotherapy. Then the debate has created, and everybody has failed to resolve that debate, how it has happened. So it took nearly more than 20 to 25 years. Then Genevieve Glass, he statistically combined the findings of around 375 psychotherapy outcomes, then concluded that Hans was wrong. Psychotherapy indeed it has a positive effect. Then he called it as meta-analysis. Then after that, it is applied in especially the medicine field, then social science research. Then coming to meta-analysis, it's placed under a broad family of literature review. Means, literature review means we all know that generally we synthesize the previous studies on a particular topic. So, but literature reviews that differ along several dimensions, right? So based on their focus, based on goals and perspective and organization and what are the audience, then method of synthesis. So among these, there are two dimensions that are very important to meta-analysis. One is focus, and another one is method of synthesis. Generally, the theoretical reviews that focuses on what are the theoretical developments that is happening or happened in the particular field. Whereas survey review focuses on typical practices, means what are the methods practicing in a particular research area. I mean, especially in clinical trials, which type of treatment is going on and what are methods they are using. So that kind of focus is on survey review. So then we have research synthesis. The research synthesis, the main focus is on research results. That means that it is not that all reviews whose focus is on research outcomes are meta-analysis. No. What distinguishes meta-analysis from other review is method of synthesis. So from the bottom left to right, that is qualitative to quantitative reviews. So in this bottom left, we have narrative research. Here, what researcher is doing is he generally evaluate the relevant studies on a particular topic and draw a conclusion. Somehow he draw a conclusion. That somehow is a limitation to this qualitative research. Because exact process, how that conclusion he has arrived at a particular conclusion is don't know. So there is a room for subjectivity bias. Then we have word counting. Word counting, we have generally what we do in word counting is we just see the significance of particular studies, whether it is a positive significant particular research or negative significant or non-significant. So under word counting, we have two methods like informal word counting and formal word counting. In informal word counting, we draw a conclusion based on majority rule. Suppose if majority of study shows that it is a positive significant, then we will say that it is positive one. And the other same way as in the opposite case, if majority of studies shows negative significant, then we can say that that particular treatment is not much significant. So in formal word counting, here we do little statistical analysis. We do type 1 error we estimate, and based on that we will draw the conclusion. Then extreme right, we have meta-analysis. Here what we do is we will do a statistical analysis and we will estimate the effect size. We will estimate effect size and then draw a conclusion. Then coming to meta-analysis versus systematic review, there is a misconception that meta-analysis and systematic reviews are both same. No, it is not the case. There is a slight difference. So in systematic review, which answers a very focused research questions, meta-analysis is a subset of systematic review. Okay, when the systematic review that has a statistical synthesis and generate a single number, that is effect size, then it becomes meta-analysis. So systematic reviews can be a standalone, means with or without meta-analysis, systematic review is there. So if it include a meta-analytic component, then it becomes meta-analysis. So we can say that meta-analysis is that portion of systematic review which involves statistical analysis. So not all systematic reviews include meta-analysis, but all meta-analysis are you can find in systematic review. I hope I'm clear. Then when one can do this meta-analysis, it is not like that you have information and you have plenty of information and you can conduct this analysis. So meta-analysis is applicable to collection of that research which are empirical, rather than theoretical, and research should have quantitative results rather than qualitative. Our focus is on quantitative results. Then research has to same relationship. It is not like that you are one within study, you are different relationship, you are quantifying and you can't do that. Then findings of research has to be arranged in a statistical form so that we can compute the effect size. So some results are they are represented in such a way that you can't compute any other you can't do any other analysis from that information. There is no use, and those results should be comparable what you are trying to answer. Then coming to the some of the basic steps is first step is define research problem, then literature search. Second step, in third step, you extract the data, and after that you calculate effect size, then apply the statistical methods, and after that your reporting and presentation of interpretation of results. We'll go one by one. The first step of meta-analysis is define your research problem. So generally, before starting the analysis, you have to formulate your research hypothesis, which you are going to prove or disprove. Okay, that's generally we do in primary research also. So once you formulate a hypothesis, then define the variables which you want to include, like outcome variable which you are interested to study, like for example yield, cost, whether you want to see the effect of particular treatment on or particular technology. Then derive the research design. Then second step, once you have formulated the hypothesis, then second step is literature search. So in literature search, it's a very important step in this analysis. First, for that you have to develop a sampling frame, like we do in primary study. What information you are going to collect, what are the information you need. Then you have to define a inclusion or exclusion criteria for the studies you want to include. So you have to develop a set of criteria for the studies which you want to include. For that, you need to define a proper clear-cut definition of your variable interest. Then what sample characteristic you are looking for. Then which studies design you want to include. Then what time frame the publication you want to include. Which period you want to include the publication. Then publication type, whether you want to include only journals or book chapters or some other reports, that you have to specify. And another criteria is publication must have the effect size information. That is the necessary condition. So once you develop the criteria for selection of studies, then search, you have to plan your search strategies. You have to search the studies in the computerized database, like Google Scholar is one, Science Direct, Scopus. You can search the literature in these database. Then while searching, before searching, you have to develop the keywords which you want to study regarding your problem, or you want to search studies. So once you have already defined the your database, then you have initial list of studies. So if those studies are enough, then go to next step. You take input from the expert of a particular field which you want to do analysis. If studies are not enough, then go to backward search and forward search. Each study you have to read, complete study you have to read. So while reading, some of these studies which are relevant to your research, that might be cited in particular that publication. So go back to so that you can include if it is relevant to you can include. So that's why it's called backward search. Then same way is a forward search. Here what we do is we try to find the studies that cite the studies you have. I have my study I have conducted in 2014. So some studies might have cited my study. So that studies may be relevant to your problem. So you can include those studies also. If then again the same step, if studies are enough, then you have your final list of studies. There are searching tips. While literature search, it is better to use Boolean operators. The Boolean operators like and, are, not, and the hyphen or minus symbol. So these Boolean operators must be entered in the uppercase. While whether you can search in it in Google Scholar or Science Direct or Scopus, you have to enter in uppercase. So if and the Boolean operators, what it does is it will limits the results. For example, if you want to search the vegetarianism and obesity, so it will search all the studies which contain both vegetarian and obesity. Your search will result in these two contents. Then if you want to include or, suppose if you want to for example, scholarly or academic. Okay, if you that leads to that search will results whether either scholarly term included in the publications or academic term, either of the one it will take. Then suppose if you want to exclude a particular term in your search, then you can use a not term. You can use not or this hyphen or minus symbol. So for example, Beers and Chicago. So before Chicago, if you add this minus symbol, the result shows only the Beers. So if along with Chicago is there, then that study will not appear in your search. Then if you want to search in different synonyms, you can use the tilde symbol. So if you include before that particular word a tilde symbol, for example, academic, so it will search all related terms of academic, okay, and its synonyms. And you can use the quotation mark if you want to search the exact phrase. You don't want any synonyms, you want to search only that particular phrase. So for example, heart attack, if you put a quotation mark, then it will search, it will take only the heart attack. So for your grouping should be clear. It should not be, it should not be unambiguous. So for that, it is better to use parenthesis, okay, parenthesis. For example, instead of searching A or B and CRD, you can use this parenthesis A or B, then and CRD. So it is very clear. So these are some of the searching tips while searching your literature you can use. Then once your final list of studies are there, then the third step is you have to extract the data and coding of the data. Okay, so first you construct the coding protocol, that what variable you want to include, what information you want to take from that particular study. Then initially, it is better to extract all the information which is available in the study, so that if you want to use in later stage, so that it will readily available. Otherwise, you have to again go back to that study and you have to read once again. So it's time consuming. So initially is you have to extract the data from all the relevant informations from the studies. Then after extraction of data, then final you have to select the data based on quality. That is again based on your analysis, which you want to conduct, which variable you want to include. Then data is ready. So this is a typical database, which we try to see the what is the effect of impact of different sustainable agriculture practices and carbon sequestration. So these are the studies we have included in our analysis. This is a hypothetical data. Okay, this is the database. This is the study ID, author, year of the publication, then which journal you are including, then location, state, then replication of your control and treated, then different copying system. We want to include the climate one, so which climate the particular study has conducted, then rainfall information, then duration, and then texture we want to include. So this is your mean effect size. Okay, this is the mean one. This is information is already there in your studies. So this is the control one. This is the treatment one. So this is the control one. This is the unit. Okay. So this is how you have to prepare your master sheet. So once the data set is ready, then you have to estimate the effect size. When data set is ready, you have to estimate the effect size. Effect size, they are very important. They are key to meta-analysis. They are the dependent variable. All our analysis is dependent on these effect size. So it's a dependent variable, and it's a quantitative measure, and that measures the magnitude of effect. And we will represent it as a summary statistics in analysis. So larger the effect size, there is a strong relationship between two variables. So there are different effect size based on the availability of data, so that you have to calculate which is suitable for your data. So based on mean, we have raw difference mean, that is simply a difference between the treated one and controlled one. Then we have standardized mean, that is also called as Cohen's d. So if you are using the pooled standard deviation, then response ratio, that is simply a ratio of your treatment and control. If your data is based on binary, if data contains binary information like yes or no type of information, then we have risk ratio, odds ratio, and risk difference. And if data is regarding this correlation data, if you have, then correlation itself is a effect size. Then how to select effect size? You know, there are certain criteria for the selection of effect sizes. So first is that should be comparable to across different studies. Then effect size should be, you know, it has to be estimated from whatever available information in that particular study. So it is not like that you are taking information from other source, but it is better to select that effect size that which is easily compute from what information you have already have. Then it has to be a good technical properties. That means you can estimate the standard error from that particular effect size. Then it has to be interpretable. So this is these are the types of data and which effect size better for that I have already explained. Then once you have estimated the effect size, you know, finally we are step 5, that is the analysis of data. First, you have to estimate the independent effect size for each study. For each study, you have to estimate. Then you have to give weights to them by using inverse variance method, or simply you can based on sample size you can give weights. You know, larger because you know each study has different sample size, so you can't combine it. So larger sample size should give more weights, and smaller sample size studies which are smaller samples should give less weight. So after that, you have to determine the confidence interval of mean. So once your weighted mean of effect size is estimated, then you have to determine the confidence interval, that is lower and upper one. Then go for analysis test of the homogeneity test. You have to need to conduct a homogeneity test. Means that whether the effect size what we have estimated is from same population or not. So if it is homogeneity there, you can directly combine it to a single measure, because initially we created the individual independent effect size, right? For last you have to give you have to estimate the summary one. For that summary, if it is homogeneity is there in among different effect size, then you can directly combine it. If there is a presence of heterogeneity, that is in general, in theory homogeneity is there, but in reality, you know, several studies they conducted across different location, different climate, so you can't directly combine it. So there is that leads to bias. So once if you are rejecting the homogeneity, then you have 2 options. So you can use either fixed effect model or random effect model, or you can use combination of both. So in fixed effect model, that assumes that the variability in effect size is systematic, means that is only due to sampling error. So you can simply that can be explained through between study variance. So it will assumes that variability is systematic, fixed effect model. But random effect model, it will assumes both sampling error and also variability in population effect. So it will means it assumes that variability is random. So again, you have to repeat this from this step. Okay, again you have to estimate your effect size, then confidence interval, then analysis of homogeneity. If it is homogeneous, then your model is good. So then third model is you can use combination of both fixed and random model. So why we are doing it is we are just like, you know, you can't simply take the average of individual studies. Okay, that's create a bias. So in order to combine the different effect sizes and generate a single effect size, for that we need a different models. Then once we have estimated the effect size, then interpretation. Okay, interpretation is interpretation and reporting of our results. So once you have estimated, it's based on our judgment that which type of estimate, which type of effect size you are using, and what is our purpose of research. So there are, if you are in specific methods of different interpretation. So one way to is that if effect sizes are consistent, Okay, there is no variation between study effect between study effect sizes. Then you can simply report the summary effect. So, but if effect size vary modestly, I mean they vary from study to study, then also you can report the summary of effect size, but you need to report the dispersion in effects. So how much variance is there? Then third is if it is substantially effect sizes are varying between study, then our focus is not on summary effect, its focus is on variance. Then you have to report results of individual studies. You can't combine. So one way, another way reporting is to create a forest plot for individual studies as well as the summer studies. Then you can beautifully create this forest plot. I will show you how you can carry out. Then coming to limitation, one of the major threat in meta-analysis is a publication bias. If there is a bias in studies, results are also biased. That you can easily you can see if effect sizes are quite large. So you have to check whether there is a presence of bias, or what will happen. And generally, studies which are positive result and significant positive, they are most likely to published than negative findings. Negative findings nobody will want to. In general, the journals, they won't publish it, so they will publish only the positive one. So there is a chance that we are including only this positive results and we are excluding the other findings. Then other source is gray literature. So if you are including studies from gray literature, that is also one of the potential source of bias. Then there is a chance that availability bias means if we are including only those studies which are easy to accessible, then it will create a availability bias, because other studies also important. You have to include all the studies. Then we have cost bias, means we will include only those studies which are freely available, because there are lots of studies which you have to pay, but because of financial constraint or limitation, if you are not including, but you are including only the freely available, then it will create cost bias. Then another source of bias is familiarity bias. If we are including only studies from our own discipline and we are excluding from multidisciplinary studies, but that is also very important to including our study. Then duplication bias, that there is a chance that significant results, there is a chance that they're likely to publish in more than one journal. So there is a chance that you have to carefully see that whether the same results are published in different journal and we are including it. Then citation bias. Citation bias here, generally the studies with this positive and significant results, they will likely to cite more cited by the other are also, it's very easy to identify, you can see. Then how to identify bias? So there are two methods. One is funnel plots. You can see the left side of the funnel plot. Some studies, they are outside this straight line. So these are all there is asymmetry in this funnel plot. So it's a case of publication bias. If at all there is no bias though in our study, so all these studies should be within this straight line. Within the straight line, and there is a symmetry in plot. So by the way, we can say that there is a publication bias in our study, and you can plot and you can always check it. So another way is to confirm the publication bias is Eggers test. So here, you just run the regression with your dependent variable, that is response ratio and the standard error. So our null hypothesis is that there is no small study effect. So your P, you can see here, it is non-significant. That means there is no publication bias. If bias is there, then P it shows there is a significant bias. You can see. So if there is a bias, then how to address the publication bias? So one way is to identify and include the unpublished studies. Generally we include only the published studies. So it is better to include unpublished one because they are also very important. Then you evaluate whether there is a difference in effect size in published and unpublished. For that, you need to do the moderator analysis versus published versus unpublished one. If results shows there is significant difference, then there is a presence of publication bias. Then you can do one option is you can interpret results published and unpublished separately, or else there are other methods to address the publication bias. This is the trim and fill method. This is one method to address the publication bias. It's a iterative procedure. What it will do is it will remove the most extreme small studies from positive style and then recompute the effect size in each iteration until your funnel plot becomes symmetric. That is, and it will give a new effect size. So first step, what this method is do is it will first delete the studies which are contributing bias. You just see in this graph, you forget about this filled open circle. There is a still space in this left side of this funnel plot, right? So it's a case of publication bias. So in first step, what it will do is it will delete studies one by one, which are responsible for publication bias, then re-estimate the effect size until that your funnel plot is significant. Then in second step, what that procedure it does is it will restore the previously deleted studies and impute that mirror image and re-estimate the your effect size. You can see first step, it has deleted these two studies, and here these two studies and these studies. In first step, the software has deleted these studies and then computed the effect size. Once the funnel plot becomes symmetric, then it will exact replication of your original studies. You can see here the filled circles. These are all imputed one in the negative side. So it will do iterative process till that plot is symmetric. This is the one way of to overcome the publication bias. So there are other limitations of meta-analysis that some critics say that it's only based on quantitative one. So it doesn't include the qualitative parameter. So, but that is also very important to include the qualitative factors to a particular studies. Then apple and orange problems. We are in this analysis we are including diverse studies. So you can't compare one study to another study. So, but the problem is that if you are you want to draw a conclusion for a very narrowly defined population, then it is a problem. And but you are including studies from all the areas and you are drawing a conclusion, then it is a problem. But you want to draw a generalized conclusion. For example, you want to draw a conclusion about fruits. So then you can include apple, orange, not only apple, orange, you can do all the other fruits so that you can draw a conclusion about fruits. Then this is not a much big problem. Another limitation is foil drawer problem. That is publication bias that, generally the results which are positive and which are significant, that only published in public domain. And several research, we have failed to find the what results we want to find. So sometime negative results are there, but those results they will not publish. So they are hidden in our research. They are simply we will keep in our computer that because that never be published. So that is one problem. But that information is also very important. Another is garbage in, garbage out. Means if you include very poor quality of primary studies, then it leads to a poor quality of results. That is one problem. Then if you include the multiple findings, that is duplication. That's I already told, duplication of studies. But here if you want to include the different observation from the same studies, there are methods that you can average it, or you can do weights. So these are some of the limitations of meta-analysis. So you can read further. There are books, some books, very important books like Applied Meta-Analysis for Social Science Research. That's very important. You can go through it by Newell Accord. Then This is Introduction to Meta-Analysis by Michael Borenstein et al. So these are very important books you can go through. So this is how these are the theory behind the meta-analysis. So now we will see the case studies. We did meta-analysis for conservation agriculture. Okay, so to study the determinants and impact of conservation agriculture in South Asia. So we already know that modern modern conventional agriculture, they are having negative impact on natural resources and greenhouse gas emissions. So one approach is conservation agriculture. So through conservation agriculture, we can avoid such problems. So conservation agriculture is and basically it's based on three principles, that is zero or minimum tillage and crop rotation and permanent soil cover. So our research question is, we formulated that whether conservation agriculture yield more or not. If yes, then which crop or region and soil that provide better outcome. So is there any cost advantage there in conservation agriculture? And if at all, then is there any significant environmental benefits from the adoption of conservation agriculture? So specific objective of our study was to examine the impact of conservation agriculture on crop yield, water use, carbon sequestration, cost on net returns, and GHG emission. So the data collected from various scientific literature on yield, water use, GHG emission, carbon sequestration, and economics in South Asia up to 2019, we have collected the literature. So a comprehensive literature search was done in online database like Science Direct, Google Scholar, and Scopus. So these are the keywords we use to search the literature, and in combination of different keywords. So then we defined the literature selection criteria, that studies have to field experiment that has to compare side by side that no tillage and your conventional tillage. Then crop yield has to be reported in that particular study, and other information like crop residue management and some other information has to be there in that particular study. Then location of the experiment. Then we excluded the results of same study which is reported in more than one paper. So this is the summary of data. Total around 1195 observations were included for the final analysis from 161 studies. Out of that, the 920 observations from zero tillage and 275 observations from minimum tillage. These are the different crops which are included in the analysis. Then we check the publication bias. Is there presence of publication bias? So here, by using this funnel plot also, it shows there is no publication bias because all the studies are within the state line. There is a symmetry in funnel plot. Then that is confirmed through the regression of Eager-Ganger test. So there is no small study effect in our study. So our p-value is not significant. Then coming to tools of analysis, so we use the descriptive statistics and response ratio, then paired t-test, and we use the mixed model. So this is the results. Okay, this is how we reported. We estimated the response ratio. So what we found was, if you adopt all the three principles of CA, that is no tillage, minimum tillage, mulching, and crop rotation, then there is a positive effect on yield. That is, response ratio is more than 1. Means your interpretation is if it's a ratio of treatment and control. Okay, ratio of conservation agriculture yield and ratio of conventional agriculture yield. So if ratio is 1, that means there is no effect. If ratio is more than 1, means positive effect. If ratio is less than 1, means negative effect. So if we adopt all the three principles, then we have positive effect. If you adopt any single practices independently, then you can see the response ratio is less than 1. And if you go for the mulching along with no tillage, the response ratio, there is no effect. Then we try to see the effect of CA on different crop wise. So here what we found was the wheat impact of conservation agriculture on wheat yield is positive, whereas paddy has negative effect. So paddy conservation is not suitable for paddy. Then maize is also positive. Then pulses and oilseeds, they also show positive effect. Then coming to water saving. So here, although there is a mixed response in yield, but there's a significant water can be saved through conservation agriculture. That nearly 142 mm from rice, maize 45 mm water can be saved, and wheat 36 mm, and pulses and also around 18 mm water can be saved through conservation agriculture. Then after that, some of the environmental benefits, we try to see what is the impact on it. So carbon sequestration shows that there is a positive effect on carbon sequestration. You can sequester more carbon through conservation agriculture compared to conventional. Nearly 16.3% of carbon can be sequestration more than the conventional one. Then GHG emission here, if you adopt conservation agriculture, then there is a reduction in carbon dioxide emission, then global warming potential, then methane. But interestingly, what we found was this nitrous oxide and nitrous oxide emission was more compared to conventional tillage. So though the like carbon dioxide is less, emission of carbon less, but nitrous oxide emission is more. Then we try to see is there any economically viable for farmers. So here there is a significant yield penalty. Due to yield penalty, though there is a cost saving in conservation agriculture, but in case of rice, due to yield penalty, the net return is less than the conventional agriculture. The other crops, they have shown a positive effect, so significant net return can be there. Then after that, we try to see what are the factors which are affecting the conservation agriculture through mixed effect model. So here, these are all the response ratio, means if it is positive means positively effective, and if it is negative means negatively effective. So here our base crop was rice, and base soil we took was sandy loam, and base climate type was subtropical semi-arid. So compared to rice, CA is more beneficial for wheat, maize, and other crops. So as in case of sandy loam, CA perform better in case of silty clay loam, clay loam, and sandy clay loam soil than the sandy loam soil. Like irrigation also found positive. Though the rotation found it is positive, but the model, it has failed to show the significant result. Then these are the conclusion. What we draw in conclusion from our study is that adoption of all the three principles of CA provides better yield than the conventional one. So among different crops, wheat, maize, pulses, they positively favors the CA practices compared to rice in terms of yield. Then factors like crop diversification, crop residue, irrigation, and the nitrogen application, they are the major drivers of greater yield advantages of CA in South Asian region. So we found that the adoption of CA practices has higher returns and lower cost compared to conventional one. So judicious use of external inputs. So CA has a greater scope to combat the impact of climate change. So we concluded that though there is a minimum yield advantage in CA compared to conventional one, so but it has positive economic and environmental implication. So this is the case study which we have done. I will show you how to do it in R.
Is it over, sir?
No, now I will just demonstrate in R that how we have did in meta-analysis. Okay. So one online database is Science Direct. Okay, you can directly Okay, search your, first I will show you that how you can search the literature by using keywords and or operators. Okay, so we wanted to search the studies which are on soil organic carbon, that is on carbon sequestration. So in India, so this is the reason which we want to include in our search, and then this is the practices that we want to see in agroforestry. Then these are the different synonyms terms, or these are different terms which combination of terms we search. So if you search it, so it will show the results. Okay, 954 results. So it's very difficult to.
Doctor, your screen is not visible.
Oh,
Still in thank you slide.
okay. Now it is visible.
It's visible.
Yeah. So I think also one online database is Science Direct. You can easily search the literature studies in the Science Direct. Okay, so you can go to advanced search. These are the keywords which we used to search the literature. Okay, we want to search in India, so we termed India, included India, agroforestry, and these are the different keywords we use to search for carbon sequestration. Okay, then you just go to search. So this is how there are different results which includes these key terms. So it's showing 954 results. So you can refine on this. See what is the time period you want to include your publications, then article type which you want to include. If you are only include the research article, then you can always refine. Then also subject area, you can select the different subject areas, and access type, open access, whether paid one, and then publication type, the different journal you can refine through different journal also. So this is how we search, and you can read the abstract. If it is suitable, the information is available, is important to your research study, then you can download it. This is the first step. Okay. Share the desktops. Okay, example. Okay. Once search is over, then we have we extracted the data. Is it visible now? Screen?
It's visible, sir.
Yeah. This is the master sheet. We have downloaded the studies and we have extracted the data. There are different parameters we have included. After once your final studies are included and your data is finalized, then yeah, now the R programming is visible, or still it is in desktop mode?
Not yet.
Not yet. Okay.
Not yet.
Now it is visible. No.
No, sir. No, sir.
Just show me how to share the desktop.
You're not showing your PC. Your PC is visible.
Dilipji, are you there?
No. Studio. Yes. Great.
Yeah.
Now it is visible. Okay. So this is the we did it in our software. So I will show you how. This is the data. You have to load the library matrix, and it is a metaphor package. You have to download and install the metaphor package in R. This is the code to estimate the effect size. First, we will estimate the effect size. I will show you. So, this is the effect size. This is simply a effect size of individual studies. Okay. First, we have searched the literature. We extracted the data, and after removing outliers, and we took the final data. Then you have to estimate the individual effect size. So these are the individual effect size. They are simply ratio of your treatment and control. If you just divide it, this weighted soil organic carbon and weighted control one, you will find this one. Your natural log of response ratio. So once individual effect size were estimated, then you have to combine that effect size, and you have to estimate the single effect size. For that, you have your random effect model, fixed effect model, or combination of both. So I used random effect model because I found the heterogeneity. So this is the code to run the random effect model. Let me see, we will see the results. Is it visible, right?
Yes.
Yes. So this is the random effect model. This is the results of model. Okay, this is the estimate. This is the average one, and model shows the lower confidence interval and upper confidence interval. These are all simply a average of response ratio. That model gives a result. Okay, so you can always the back transform that result, and you can repeat based on how you want to how you want to interpret. For example, percentage change over control. Once you have estimated the results for different practices, okay, then check the publication bias. For that, you have to use the funnel plot. This is the code for funnel plot. So analysis is good. Okay, yes. This is the funnel plot. Okay, though there are some studies there, they are outside the straight line, but more or less it's a symmetric one. So you can confirm it through regression. Okay, the Eager-Ganger test. Just taking that. Yes, we got the results. You see the regression test for funnel plot asymmetry. So this is the result. You can see this is not significant. That means there is no publication bias in our study. So our results are consistent. So you can go further. So once you have estimated, you have to back transform for interpretation purpose, the percentage change. Again, it's depend on you how you want to represent your results. You can directly create this forest plot by using this estimate only. These are all response ratio only, but for the ease of interpretation, it is better to include it. Better to estimate in percentage change of time. So once it is estimated, I'll show you how it is how to. Yes, this is the data. So first I have estimated estimated the results by using this model, random effect model. Then I back transformed this one, and these are all in percentage change over control. These results shows the percentages. Suppose 18.78, 18.78% more than the control one. This is the interpretation. This is the upper bound, and this is the lower confidence interval. So, in order to represent graphical representation, you have to download and install the ggplot2. So you just install it and download it. These are the codes you can use. Yes, this is the forest plot. This is the mean, and this is the lower one. This is the upper one. So this is how you have to create a forest plot. Then you can save always. Yes. Then you can download it. You can export image as where you want to save it. So this is the plot generated by R, and this is you have to show it in your publication. Yes, I think that's all from my side. If you have any doubt, you can ask.
Thank you, sir. We request now participants, please inform about any issue, any query to our expert regarding this meta-analysis. This is a very important study. And Dr. Saab has explained both the theoretical part, and how to do this through software also. Please inform if any issue is there regarding this topic.
Doctor, thank you for your presentation.
Yeah.
I would just like to know, how did you estimate heterogeneity, or how did you test for it?
Yes. So that part I forgot. Actually, there is one Q statistic is there. So
Okay.
You can see it. You can the Q statistic there. That model itself, it will give how much it is there.
Okay, fine.
So you can see with the 15%, 20%. So it is.
I'm not able to see your screen.
It's over now. Anything more is there? Still.
Here you can see total. This is the H square. You can see, and this I square. This is the 16% of variability. You can see the model itself give, and these are the different statistics you can see. You have to see whether you have to go for fixed effect or random effect, then mixed effect, where you have to use the moderator one. Yes, this is the moderator one, mixed effect. If you want to see, let's. Yes, I have used moderator as cropping system, so it will show the results. And individual, there are multiple, there are many, there are different kind of analysis you can do based on crops, based on soil texture. You have to find the individual estimate, then back transform it. Then you can display. You can create the forest plot for individual, for soil texture separately, for rainfall separately, then for climate wise. Yes, this is the mixed effect model. Okay, here we are including all the cropping system. This is a hypothetical one, but you can see the amount of heterogeneity is R square is accounted for. So what is residual heterogeneity? So you have to report while writing the your paper. You have to report these things. So this is the estimate. The standard are already given. And this is the lower one upper one. So you can easily estimate whether it is and significant levels is also they will give. Okay. So this is how.
Any other issue is there? So now we should conclude regarding this topic. Thank you, Dr. Saab, for explaining to our participants for taking this lecture.
Thank you, sir.
I'm also very thankful to our participants for giving support to us. Thank you all. And now we will be gathering again at 2:30 for our next lecture on agents of agriculture performance. So this session is now closed. We will be again gathering at 2:30. Thank you all. Thank you all organizers also. Session is closed now.